Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session May-June 2021 Paper 2-2. So let's start with the first question. Question number 1, part A, solve the equation. So let me apply the logarithmic property. We have ln 2 plus x minus ln x equals to ln 3 power 2. So ln 2 plus x over x equals to ln of 9. So taking ln, cancelling ln on both sides, or taking anti-log on both sides, we have 2 plus x over x equals to 9. 2 plus x equals to 9x. We can say 2 equals to 9x minus x. 2 equals to 8x, and 2 by 8, this is x, and 2 by 8 is 1 by 4. So 1 by 4 is the x value, right? Now for part B, hence solve the equation ln 2 plus cot y minus ln cot y equals to 3 to ln 3 for y is between 0 to pi by 2. Give your answer correct to 4 significant figures. Okay. So if I compare this equation with the one which is given in part 1, which is ln 2 plus x minus ln x equals to 2 ln 3. Now what we have to do, we have to replace x with cot y, right? So cot y, right? And x value is 1 by 4, right? So we can say that 1 by 4 is cot y. Cot is 1 over tangent, right? Reciprocal on both sides, we can say tan y is equals to 4 and y is equals to tangent inverse of 4, right? It should be in radians, and the y values lies between 0 to pi by 2. So it should be in first quadrant. So tangent inverse of 4 in radians is 1.3258 up to 4 significant figures. Y value is 1.326 when we round up to 4 significant figures. Question number 2, the solutions of the equation 5 absolute of x plus equals to 5 minus 2x are x equals to a and x equals to b, where a is less than b. Find the value of this. Okay, so first we need to find the solution. So we have 5 plus minus x equals to 5 minus 2x. Okay, so let me do scaling on both sides. In order to get rid of this plus minus. So 5 square is 25. This is x square. This is 5 square is 25 plus 2 square is 4 x square minus 2ab. So we have 2 times 2 times 5, which is 20. So minus 20x. Shifting all the terms to the left side, we can take 25x square, or to the left side, minus 4x square plus 20x minus 25. This is equals to 0. From 25 take away 4 is 21x square plus 20x minus 25. This is equals to 0, right? Let me apply quadratic formula here. So x equals to negative of b plus minus square root b square. So 20 square is 400 minus 4ac. So minus 4 times the a value times the c value is 2100 plus 2100. We have plus 400, which is 2500, and 2 times of a, so 2 times 21 is 42. So x equals to minus 20 plus minus, and square root of 2500 is 50 divides 42. Okay, let me solve for the 2x values. What are the 2x values? We have minus 20 plus 50 divide 42. is 5 out of 7, which is 0.72, and the other is minus 20 minus 50 divided by 42 is minus 5 by 3, which is minus 1.67. Okay, so we have two solutions, A and B, where A is less than B. So it means A is less than B. This implies the A value is minus 5 by 3. This is less than 5 by 7. This is your A value and this is the B value. Okay, now we need to find the solution for absolute of 3A minus 1 plus absolute of 7B minus 1. Okay, so we have absolute 3 times of A, which is minus 5 over 3, negative 1, plus absolute 7 times of B, 5 over 7, minus 1. 3 is cancelled with 3. We are left with minus 5 minus 1, absolute of minus 6, plus 7 is cancelled with 7. 5 minus 1 is 4. So this is 6 plus 4. This is equals to 10. So the value, its value is 10. Question number 3. Solve the equation sine 2 theta plus 30 degree equals to 5 cos 2 theta plus 60 degree for theta is between 0 to 180 degree. Okay. Let me open the compound angle formula for sine A plus B, which is sine 2 theta cos 30 plus cos 2 theta sine 30. This is equals to 5. Cos A plus B is cos A cos B minus sine A sine B. So cos 2 theta cos 60 minus sine 2 theta sine 60. Right. So what is cos 30? We have to do in degrees. Right. Now cos 30 degree is square root of 3 by 2. So square root of 3 divided by 2 sine 2 theta, and sine 30 is 1 by 2 plus 1 by 2 into cos 2 theta equals to 5 into cos 60 is 1 by 2, 1 by 2 cos 2 theta, and sine 60 is square root of 3 by 2, so minus square root of 3 by 2 sine 2 theta. Okay, let me shift all the terms to the left side. We have square root of 3 divided by 2 sine 2 theta plus 1 by 2 cos 2 theta minus 5 by 2 cos 2 theta plus 5 square root of 3 by 2. When we shift this term, it is negative and this becomes positive. Yes, sine 2 theta equals to 0. Right. Now combining sine 2 theta, which is square root of 3 by 2, and 5 plus 1, which is 6, square root of 3 by 2 sine 2 theta. And we have 1 minus 5, which is minus 4, and minus 4 divided by 2 is minus 2. Minus 2 cos 2 theta. Right, 2 times 3 is 6. So we have 3 square root of 3 sine 2 theta is equals to 2 cos 2 theta. Okay, so dividing by cos 2 theta on both sides to make it tangent. This sine over cos is tan 2 theta. This is 2 over 3 square root of 3. Right. Okay. So from here we can say 2 theta is equals to tangent inverse of 2 over 3 square root of 3. The theta values is between 0 to 180 degree. Right. So let me do this. Tangent inverse 2 divides 3 square root of 3. This is 21.05, 21.1 degrees. So 2 theta is 21.1 degrees. This is for the first quadrant, right? And we know that tangent is also positive in third quadrant. So for third quadrant, we have 2 theta equals to 180 plus that value, 180 plus 21.1, which is 201.1. Let me solve for theta from here. So what is theta? 21.1 divided by 2, which is 10.55, 10.5 degrees, and 201.1 divided by 2 is 100.5 degrees. So these two values belongs to the range of theta between 0 to 360 degree, sorry, 0 to 180 degree, because 0 and to 180, so both belongs to the range. Question number 4, part A, find the exact value of this integral. 6 is outside, e power 2x plus 1, and the derivative of 2x plus 1 is just 2. Limit is from 0 to 2. 2 times 1 is 2, 2 times 3 is 6. So we have 3 e power 2x plus 1 from 0 to 2. Substituting the upper limits, 3 e power 2 times 2 is 4. 4 plus 1 is 5. Minus 3 e power 2 times 0 is 0 plus 1 is 1, right? So the solution is, we can say, taking 3 common, e power 5 minus e, right? Now for part B, find the integration of tan square x plus 4 sine square 2x dx. Let me use the identities over here. So we know that 1 plus tan square theta is secant square theta. So from here, tan square theta is equals to secant square theta minus 1, right? And the other identity we are using is for sine square theta. Sine square theta is 1 minus cos 2 theta divided by 2. So here we have sine square 2x is 1 minus cos 4x divided by 2. Right, let me use these identities in the integral. So we have integration, tan square is secant square x minus 1 plus 4 by 2 into 1 minus cos 4x with respect to dx. Okay, the integration of secant square x is tan x minus x plus 2, integration is x. The integration of cos is minus sine 4x over 4 plus some constant of integration, right? Okay, so we have tan x minus x plus 2x minus 1 by 2 sine 4x plus some constant of integration, right? So here we have tan x plus x, because minus 1 plus 2 is just 1, minus 1 by 2 sine 4x plus c. Question number 5, part A, find the quotient when fourth degree polynomial is divided by x minus 2 whole square, and this is x square minus 4x plus 4, and show that the remainder is 7, right? Let me do the long division method over here. So x square minus 4x plus 4 is the divisor, all right, and the dividend is x4 minus 32x plus 55, and we need the quotient at the top. Okay, so first we have to multiply x square with x square to get x4. So x square, we have x4, x square times x square minus 4x cube plus 4x x square, right? Now let me subtract this. Positive, negative, positive and negative. This is cancel. We have 4x cube minus 4x square minus 32x plus 55. All the terms, cube term, square term, x term and the constant term. 4x cube we have to make, so add 4x, multiplying with 4x we have 4x cube minus 4 times 4 is 16x square, 4 times 4 is 16x, right? Again subtracting, so we have negative, positive, negative, this is cancel out, and 16 take away 4 is 12 x square, and we have negative 32 negative 16 is minus 48 x plus 55. Okay, so add 12, this is 12x square, 4 times 12 minus 48x, and 4 times 12 is 48, right? Again let me subtract this, we have to change the signs, negative, positive, negative, this is cancel out, and 55 minus 48, 55 minus 48 is 7, so the remainder is 7. We have showed that the remainder is 7, and the quotient we got is x square plus 4x plus 12, right? This is a quotient. Now for part B, factorize x4 minus 32 plus 48. Okay, so in part A we have given x4 minus 32 plus 55. So how can we write this as a remainder theorem? So we can say x4 minus 32x plus 55 divided by x minus 2 whole square. This is the quotient is x square plus 4x plus 12, x square plus 4x plus 12 plus 7 is the remainder, and the divisor is x minus 2 whole square, right? Now we have to make this 48. 55 take away 7 is 48, so subtracting 7 on both sides we can say, right? So x square minus 32x plus 48 when we subtract 7 over x minus 2 whole square, this is equals to x square plus 4x plus 12, so 7 was a remainder, now 7 minus 7 would be 0 over x minus 2 whole square, right? So we can say x square, x power 4 minus 32x plus 48, this is equal, this term is 0, so you have to times this, the factors are x minus 2 whole square into x square plus 4x plus 12, right? Now for part C, hence solve the equation giving your answer in an exact form, right? Okay, if I compare this with part B, we have x power 4 minus 32x plus 48. This equals to 0. So it means x minus 2 whole square and x square plus 4x plus 12 equals to 0, right? If I compare with this one, this is 48 minus 32, so x value is e power minus 3y, right? So it means we have to replace x with e power negative 3y and e power negative 3y, so x4 is we have minus 12y, yes. Okay, so how can you find factors? We can say x minus 2 whole square equals to 0, so this is e power minus 3y minus 2 whole square and e power minus square and square, so 3 times 2 is 6y plus 4 e power minus 3y plus 12, this is equals to 0, right? Let me simplify this. We can say e power minus 3y minus 2, this whole square is equals to 0, and e power minus 6y plus 4 e power minus 3y plus 12, this is equals to 0. Taking square root on both sides, we have e power minus 3y minus 2 equals to 0. Then e power minus 3y is equals to 2. Taking ln on both sides, so minus 3y equals to ln of 2 and y equals to minus 1 by 3 ln 2. Right. This is the exact value of y. Now let me solve the y from here. So we have e power, if I use a quadratic formula, so e power minus 3y, this should be equals to minus b plus minus square root, b square is 4 square is 16 minus 4ac. So minus 4 times the a value is 1 and the c value is 12. This is negative of 48 divided by 2. So 16 minus 48, you will get the complex root from here. So the only solution is y equals to minus 1 by 3 ln 2. Or if you don't want the negative sign, so y would be equals to 1 over 3 ln of 1 by 2. Minus is in the power, minus 1 is 1 by 2. Question number 6. The diagram shows the curve with equation. This is a curve y equals to ln x whole square minus 2 ln x. The curve crosses the x-axis at points A and B and has a minimum point at M. Part A, find the exact value of the gradient of the curve at which the points at each of the points A and B. So we have to find the exact value of the gradient of the curve at each of the points A and B. So first we need to find the coordinates of A and B, right? Coordinates of A and B. As we know that the curve cross x-axis at A and B, so means the y coordinate is 0. So some x coordinate and y is 0, and it has some x value and the y is 0, right? So in the curve, if I can substitute y equals to 0, what is the curve? Ln x whole square minus 2 ln x, this is equals to 0, right? So we can say ln x whole square equals to 2 ln x, right? So 2 is outside, ln x, no, it's a square, sorry. Keep this as it is, equals to 0. Taking ln x common, we are left with ln x minus 2 equals to 0, right? Now we have two factors, ln of x equals to 0 and ln of x is equals to 2, right? So the x value is e power 0 and here x value is e power 2. E power 0 is 1, x is 1, and here x equals to e power 2. So these are the coordinates of A and B. So what is e power 2? E power 2 is 7.3. So this is the B value. Yes, this is a coordinate for A and this is a coordinate for B. Right, now let me find the gradient. So for gradient we have to do dy by dx, dy over dx, which is d by dx of ln x whole square minus 2 ln x, right? So we have to use a power rule first here, which is 2 ln x, 2 minus 1, and the derivative of ln x is 1 over x minus 2 times 1 over x, right? So this is 2 ln x over x minus 2 over x. This is a gradient at point A and B. Now let me substitute the point x equals to 1 and x equals to e power 2. At x is equals to 1, we have dy y prime is equals to 2 ln 1 over 1 minus 2 over 1. right? What is ln1? Is 0. ln1 is 0, so this is -2 at point A, right? At x equals to e power e square. So y prime is 2 ln e square over e square minus 2 over e square, right? So this would be ln of e is just 1, so we have to shift this power. So we have 4, 2 times 2 is 4, e power minus 2 e power minus 2. This would be equals to 2 e power minus 2. So we can say that the exact value of the gradient of the curve at point A is -2 and at point B is 2 e power minus 2, right? Now moving to part B, find the exact x coordinate of M. And what is M? We know that M is the minimum point, right? And for minimum point we have to put the gradient equals to 0, right? So y prime should be equals to 0. We have the gradient we got is 2 ln x over x minus 2 over x. This should be equals to 0. Taking 2 by x common, we are left with ln x minus 1. This should be equals to 0. So from here 2 over x equals to 0, or ln x minus 1 equals to 0, right? So from here 2 is not equals to 0 because x times 0 is 0. So ln x equals to 1 and x equals to e power 1. So this, the x coordinate of M is the minimum point is E, right? Number 7, the diagram shows the curve with parametric equation x in terms of t and y in terms of t for t values between 0 to 1. The point P on the curve has parameter p and y coordinate is 3. Part A, show that p is equals to 1 by 2 sine 2p. Okay, so we have given the information that the y coordinate is 3. So equating this y with 3, y equals to 3 and y equals to this. So 6t, the parameter is p, right? So we have to use 6t sine 2t equals to 3. So t is replacing with p. Instead of t, we have p. So we have to solve for p. So 6p sine 2p equals to 3. 3 times 1 is 3, 3 times 2 is 6. So what is p? P equals to 1 over 2 sine 2p. So it's proved. Now for part B, show by calculation that the value of p lies between 0.5 and 0.6. So if the p values lies between 0.5 and 0.6, it means the sign change occur. So we can say at 0.5, 1 over 2 sine 2 times 0.5. Let me check this. It is in terms of, okay, in radians we can calculate. Okay, 2 times 0.5 is 1, and sine 1 times 2, and the reciprocal is 0.6, we can say. So 0.5 is less than 0.6, right? Now let me check at 0.6. 1 over 2 sine 2 times of 0.6. 2 times 0.6 sine of answer times by 2 and the reciprocal. This is 0.5. Okay, so 0.6 is greater than 0.5. So the sign change occur. This implies root lies, or the value of p lies between 0.5 and 0.6, right? Now for part C, use an iterative formula based on the equation in part A, so which is Pn plus 1. This is 1 over 2 sine 2 Pn, and to find the value of p correct to three significant figure, use an initial value. So p naught we have to use 0.55, which is given, and give the result of each iteration to 5 significant figures. Right, let me make a table of values. We can say pn is here and pn plus 1 is here. Okay, up to 5 significant figures we can calculate it. The first value is 0.55, and the equation is pn plus 1 is 1 over 2 sine 2pn. Right, so if I can say 1 divides 2 sine 2 times pn is 0.55. This is up to 5 significant figures. 0.5, 1 2 3 4 5 up here, 0.5610, and 3 rounded to 4. Right, okay, now 0.56104, we have 0.5549 and 3 rounded to 4. Yes, 0.55494, 0.55826. Right, now for the next one, 0.55826, 0.55643. Right, again 0.55643, 0.557 and 3. One more, 55743 is 0.55689. Okay, and up to so on. Let me find the root up to 3 significant figures. Right, so we have 0.55, this is 0.55, this is fixed. Right, now we have 4 rounded to 5, this is 8, this is 6, this is 7, and this is 7. So 0.557 is the root. Right, let me complete this column as well. 0.56104, 0.55494, 0.55826, 0.55643, and 0.55743. Right, now for part D, use the gradient of the curve at P. Find the gradient of the curve at P. So for the gradient of the curve, we have given x, which is 4t plus e power 2t, and y we have given 6t e power sine 2t. All right, let me find the derivative. Dx over dt, 4 plus e power 2t times 2, which is equals to 4 plus 2 e power 2t. What is dy over dt? 6t is as it is. The derivative of sine is cos 2t times by 2 plus sine 2t is as it is. The derivative of 6t is just 6. Right, so we have 12t cos 2t plus 6 sine 2t. Right, applying the chain rule here, we have dy over dx is dy over dt times dt over dx. Right, okay, dy over dt is 12t cos 2t plus 6 sine 2t It's times by 1 over 4 plus 2 e power 2t, the reciprocal of dx over dt, right? This is a gradient of the curve. Now we have to find at point P, right? So at point P we have given, this is the point P, and the point P on the curve has a parameter P. Okay, so we got the value of P from part C, which is T is basically P, and this is 0.557, right? So we can find dy over dx at t is equals to 0.557. Let me calculate this. Okay, so 12 into 0.557 cos 2 into 0.557 plus 6 sine 2 into 0.557 times 1 over 4 plus 2 e power 2 times 0.557, right? Let me calculate this. 12 times 0.557 is this, into times cos of 2 times 0.557 plus 6 sine 2 times 0.557 is this. Okay, and then divide it by 4 plus 2 e power 2 times 0.557, 0.8256, 0.826, you can say is the exact value, 0.826, right? So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.